Hello, everyone. Good morning, good afternoon, or good evening, depending on what time you're watching this video. It's me again, Teacher Kent, and today we are going to answer your book. Okay? I am going to give this to you as a homework in our next class. But so that all of you could get a good grade in the next class, the next homework, we're going to answer this together. Okay? So, before anything else, please get this. Please get your science book. Okay? We are going to answer page 79. Page 79. Okay, just let me prepare what we are going to answer. So hang on just a bit while I open the picture because I took a photo of my book so that you or we can answer it together. Here is the photo. Okay, that's it. That's the photo. This is page 79. By this point, please get your book and pencil or pen. It's up to you. But make sure to pause the video when you're going to get your book so that you can answer along with me. And let me just make myself a little bit bigger so that you could still see my face. Okay, let's start, shall we? What have I learned about forces? It's time for us to know if you guys understood what are force or what is a force. First, we can use a blank to measure force. This is one of the first things I told you during our class. Do you remember? How do we measure force? What type of instrument can we use to measure force? Of course, is it a weight, a texture instrument, or a spring balance? What do you think it is? It's a spring balance. That's right. You can use a spring balance to measure force, just like what you can find in your book. Now, let me just so that we will not forget what we already answered. We'll put a small X, a mark there to know that we're finished with spring balance. Let's go to number 2. Force is measured in blank. Okay, how do you measure force? You use spring balance. But what is the unit of measurement? Remember, if it's speed, it's meters per second. But what about force? How do you think, or what do you think is the unit of measurement for force? Force is measured in Newton. Okay? Force is measured in Newton, just like your classmate, Newton. Okay? And now let's just write it here so that we don't forget it or we don't need to answer it again. The arrows in a force diagram show the direction and blank of the arrows acting on an object. Remember the force diagrams that I have shown you before when we computed for the resultant force? If you have, tell me. It shows the direction, right? If it's pointing there, you know that it's going to the left. If it's pointing there, you know it's going to the right. So my question is, aside from the direction, what else does the arrow tell you? It tells you, I'll give you two choices. It tells you the weight or It tells you the magnitude. It tells you the magnitude. Magnitude is like how much force is there, okay? So in a force diagram, you can see an arrow. It shows the direction and the magnitude or the forces, the amount of forces acting on it. So let me just erase magnitude right there. Number 4, in a force diagram, the longer the arrows, the blank the force acting on an object. Oh, if you see a force diagram and if you notice that if the arrows are almost the same size, it means that the arrows probably have almost the same force or amount of force, right? But the longer the arrows, the blank the force of the object. The what? If it's longer, is it slows down or slipping or greater? Okay, I'll give you three choices. Is it slows down, greater, or slipping? It is greater. In a force diagram, the longer the arrows, the greater the force acting on an object, meaning the stronger the force. So it's greater. Okay, don't also forget to mark that down. Number 5, the blank force is the single force that has the same effect on the object as all individual forces acting together. Okay, if you did not understand, let me repeat. The blank force is the single force that has the same effect on the object as all the individual forces acting together. What do you call the final force in a force diagram? Remember, if there's a person that's pushing to the left, 10 newtons, and a person pushing to the right, 5 newtons, the final force will be 5 newtons to the left because 10 minus 5 is 5. And the greater force is to the left, so it's 5 newtons to the left. So what do you call that? That is the resultant, okay? That is the resultant force. Okay, then don't forget to mark it down. Okay, number 6. The direction of a moving object depends on the blank of the resultant force acting on it. The direction of a moving object, what it depends? It depends on blank of the resultant force acting on it. Of course, the direction of a moving object, it will depend on the direction of the resultant force. It's the same word, okay? It's the direction of the force. Don't forget to write a line to cross out direction. Now that is number 6. Let's go to number 7. Blank is the force that goes against movement. Oh, what type of force goes against movement? Do you know, class? The force that goes against when you move something. I think you know what it is. We just finished talking about this last time. It starts with letter F. It's friction, okay? Friction. Friction is the force that goes against movement. Let me just mark the text so we will know. Okay. So those are our choices. Let's go to okay. We're gonna clear all of this up. And let's continue with number 8. Okay. Let me just make this a little bigger so you can still read. Okay. Sadly, we had to erase some of the choices, but you can just go back to the video and answer it. Copy the previous answers, okay? Number 8, friction occurs when two blanks rub against each other. Oh, when does friction happen? We said that friction happens when there is force. So where does friction happen? Friction occurs when two what? Two slows down, two weights, two direction, two surfaces, two texture. Rub against each other, it's surfaces, okay? Friction occurs when two surfaces rub against each other. It's when one surface is touching another surface, like your two hands together, and you do like this. After a certain period of time, your hands will become hot. That is because of friction. Okay, two surfaces rub against each other. Number 9, friction acts in the blank direction of a rolling ball, and it will slow down and eventually blank the movement of the ball. Okay, let's answer this one by one. Friction acts in the blank direction of the moving ball. If I kick a ball to the left, friction will also be going to the left or to the right. It will go to the right. So friction acts in the opposite. Okay. Friction acts in the opposite direction of a rolling ball, and it will slow down and eventually blank the movement of the ball. What will happen to the movement of the ball? When you kick a soccer ball in the field, what will happen to, after a certain amount or period of time, what will happen to the rolling ball? It will stop, or it will stop the movement of the ball. Okay? Stops or stops. Number 10. Friction depends on the blank contracting surfaces and the blank of the object. Oh, we said that the surface touching each other, it creates friction. But some surfaces have more friction than others. It's because of the what of the surface? What do you think? It's because of the texture. Okay? It's because of the texture of the surface. If one surface is rough, it will make the ball stop moving faster. If one surface is smooth, it will take a long time for the ball to stop moving. And the blank of the object. What else? And the weight of the object, okay? And the weight of the object. An object that is heavier will have more friction. Thus, it will slow down faster compared to other objects. Okay? Let us now go to the last two numbers. Friction allows movement, allows objects to move without blank. Oh, what does friction actually do aside from stopping movement? What is the good thing that friction helps us in? Friction allows objects to move without slipping. Okay? Friction allows objects to move without slipping. What does that mean? It means that the object will not slip. If there is no friction, class, we cannot walk. We will just continuously fall down and slip because our feet cannot hold the floor because we need friction to actually touch or move objects or even move our walk or even to walk. And number 12, our last number, class. Friction blank all moving things. What does friction do? Friction slows down moving things, okay? Friction will slow down moving things. Friction is actually both good and bad for us. Bad because sometimes friction causes heat that breaks objects. Good because it allows us to hold on to things, or like how we hold on to the ground using our feet to walk. And that's it. Those are our homework. So please write that down because I am going to give you that homework next time. So that's it for today. I hope you enjoyed, and I'll see you next time. Bye.